Okay, we're going to go ahead and get started. Everybody hear us okay in the back? You guys are good? Okay. Thanks for coming out. So the title of this talk is Blue Team Keeping Tempo with Offense. The idea here is some things that we've been working on together that we think would be helpful. So we're open to feedback and challenging some of the things that we've been working on. But we just wanted to share some of our ideas on a blue team, red team working together to overcome some of the obstacles in detection. So actually, thanks to Keith, because I submitted this talk without his permission. So he got a text saying, "I got accepted to DerbyCon. Awesome?" ? So thanks to that. So go ahead.
I'm Keith McCammon, long-time DerbyCon lurker, first-time attendee and speaker. So if anything goes horribly wrong today, it'll be my fault, not Casey's.
Cool. Yeah, so I'm Casey Smith, sub T on Twitter. We're both at Red Canary, so feel free to reach out if you have questions later. So why does this talk matter? We really think that the stronger the competitor, the stronger the game, right? So the idea here is, how can we work together to both, incrementally increase both our detections and our operations? So we've got some really fun ideas about what does it really like to operate as a red team that's hunted, and what does an apex blue team look like, right? So what are the strategies and ideas around how to operate together as a team? So a lot of the things that I've come up with over the last couple of years have been a direct result of working against Keith and Joe here on the front row, like being hunted daily and not being able to get past the 90-minute mark before a detection fires. And so so that kind of stuff really drives, I think, all of us to get better. So again, what we're presenting here is really hopefully inspirational, is also tactical and technical for you guys to come up with some ideas and innovate on your own. So first of all, I wanted to go over sort of the state of things. So what we find if you're operating in an environment is, one of the things that's changed dramatically in the last couple of years is, low-level endpoint visibility is pervasive. If you're going into an environment, it's very likely somebody's instrumented that with some telemetry on the endpoint, on the network. You're likely going to get seen. So this is something that's been a good thing for blue teams. It's also changing the way we operate as a red team, because now all of a sudden things like command line visibility, netcons, DNS calls, if you saw the ETW talk that Zach did earlier today, there's just visibility we haven't had before. And so we've got to change the way we operate, or how we drive. Is this thing working? Is it actually going to detect our activity? So from a red team sort of problem or challenge, this can be definitely a difficulty that we run into. But there's also some things around some blue team challenges with this as well. So
yeah, absolutely. So working with endpoint data for a long time, right? It has absolutely changed the way that we approach detection, and it's obviously changed the way that attackers have had to operate. But it comes with some downsides too, right? So you're generating a tremendous amount of data. Most of the products that we're used to working with on the control side, but also the products that we're used to using to analyze, correlate, things like that. Those things are all built around the concept of alerts. And we'll talk a little bit about the distinction between alerts and other types of observations later. But that's been the biggest challenge, is we're not yet to the point where we have really, really good tools to operationalize this type of data at scale, balancing both breadth of detection with accuracy and timeliness. So the next assertion is just that detection and prevention have drastically improved, right? And so they're always getting better. And, you can argue that, there are some pitfalls with certain types of controls, but in general, kind of the mainstay controls, things like application control, application whitelisting, again, pervasiveness of endpoint telemetry, network collection, even, the merging or the conversion of collection of endpoint data with network data has made it much easier to do things like just basic root cause analysis, right? So from a blue team's perspective, those are super important, and probably the biggest game-changing aspect of that for the blue team is that you can take, if you do it right, you can take this massive cut off of the top of your exposure, right, and allow your blue team to operate on finding, interdicting, responding to, the top 5% of attacks, and not the entire, not the bottom 95, right? So you can kind of neck the attacker into a thing. They can't bring their own tools, so you force them to use the tools that are there. And because you've kind of necked them down into that operating space, you can put a lot of controls in place and a lot of visibility in place to watch that really closely. So cool.
Yeah, so this is application control, something I'm obviously very interested in, and changed the way I operated several years ago. And so there's been some really good research around device guard, other application whitelisting. So if you saw Matt's keynote earlier yesterday, so the idea is around, this is a game changer. Are there bypasses? Yes, but you're forcing somebody to move into an area where maybe you can focus better. So this has definitely been, again, disruptive for red team operations, where like they're forced to raise the cost for the attacker. So attacker economics, you may have heard that phrase. So the idea is, how do we drive up the cost for them to conduct their operations? Another thing that's actually interesting to me is what I call like trade craft decay, or half-life, or TTL, like the idea that you use something, and if it's innovative and novel, very quickly it's going to be shared, signature, detected, and there's just only a certain amount of time where that's actually going to be useful in certain environments. We'll go over some use cases for that. Response is faster. You have to innovate or you're going to get caught, right? If you're operating as a red team and you're continually using the same tactics over time, you're going to get caught. So there's a lot of different approaches here, but that's one of the things that's inspiring to me, is like, well, what's next? What do we think about next? What can we do next? Always thinking about, okay, so I used that on Tuesday. On Wednesday, I've got to come up with something new. I mean, those are some ideas. So.
Yeah. So this is one that it's interesting because it seems like it's objectively like great for the blue team. But you do have the exact same problem, right? Like, you've got to work harder for detection techniques that are going to persist beyond like an adversary or a tool, right? And so you really do have the inverse problem. And like, to put it into like perspective, having like done this for a long time and seen, I don't know how many like lifetimes, I guess they're measured in like RSAs of like security tools and actor disclosures and things like that. Like, the hard thing is, like, none of the old stuff ever goes away, right? So it's not like as a blue team, you can say, all right, well, like the PowerShell thing, like they got that locked down. We can just stop with that now. Like, think about phishing and like stuff like that. So, so you still have to like manage the long tail of attacks. You have to and you really have to manage for those things. Like, maybe not being used as frequently, but being used in much more in much more subtle, or esoteric ways, right? And so, so one of the things, what we'll talk about next is kind of, point of this talk, right? How can we tip things in the favor of the blue team? And so we'll start by just looking at where some blue teams like tend to traditionally break down, right? And so, already mentioned the concept of just like a lot of legacy tooling, primarily like a lot of alerting and a very just kind of like alert-driven mentality. And then overly broad test strategies. So that's one of the specific things that we'll kind of just, share some of our learnings, or at least like, hypothesis on how we can improve those. The testing thing is probably like the most interesting, I think to me, and I know to Casey, in that there's red teams are evolving, right? And so like, we've got some of the very best that there are in the room today, and like the things that they're doing differently are, we're starting to see a move in the right direction, right? Which are like longer term engagements, but also focusing on like very specific parts of like very specific tactics and techniques. It's a pretty big shift from the past, although we're still seeing a lot of the past, which is just like really broad red teams, like get in any way that you can. Like put your name on your shirt and walk in the front door with a ladder, or like fish the executive assistant, and like those are great. But there's a very small subset of organization that can digest the feedback from an engagement like that. Like, how many of you think that your organization is prepared to like address, change, improve like physical security, operational security, like supply chain, like all those things at once, right? Probably not many. So, breaking this down, just making it a little bit more digestible, making it more focused, and doing it more regularly, is probably like one of the most important things we can do, right? So, right tools, right data and information. This concept that we've talked about of like minimum viable collection, right? Which is, I think at this point, the things that we agree pretty much everyone has to have, like some endpoint data, some network data. You don't have to get them from different tools. You don't have to drop a full NSM stack if that doesn't match your architecture, or if that's, doesn't match the capabilities of your team. And, with those things at the top, that's probably the most important part, is just making sure that, you find a gap, you're going through your matrix of controls. Like, it's really, really easy to just like buy a technology, check a box, like close that thing out, move on, right? But the reality of that is like, your team probably can't deal with it. You probably don't have the expertise or the time, more likely, to manage all those things. Like, those are IT controls too, right? You've got to patch those just like you patch everything else. So like there's a lot of cost and controls, and finding the right balance between like what you put in place for visibility, what your team can manage, the capabilities of your team, if you have partners or services that you use, understanding how those fit are important. So I think the two things we want to talk about today very specifically are the concepts of what we call atomic testing, and then just kind of suppression versus alerting, right? Just like a different way to think about how we collect data, how we analyze it, and how you can kind of scale that and maintain detection depth.
So we've kind of come up with a term that we're calling atomic testing. And what these are small unit tests based on the MITRE ATT&CK framework. How many of you are familiar with the MITRE ATT&CK framework? Great. I mean, huge show of hands. So we like this framework because it codifies a lot of actual attacks that you can then drive detections for and look at. So there's very specific details on, post-compromise, lateral movement, like things about how that framework articulates. So we have found it useful, and so we're going to talk a little bit about some of our methodology with it. Just a brief overview. This is where you can find the resource. There's a white paper at the bottom of that link that sort of describes their methodology for using this. If you wanted to look at sort of where these tests that we're going to write and talk about in a minute operate, we're sort of focused here on the latter part of an engagement where the attackers got access or execution on a box. So at this point, they've got control, execute, maintain, and there's a lot of frameworks out there, right, that you can choose from, and we like this one a lot. And so we want to try and leverage prior work and things that people have done. So we're going to look at some examples of how this can be useful. So a huge shout out to Roberto. I don't know if Roberto's here. I haven't met him yet. So anyway, I want to make sure you guys saw this resource. He did a really cool blog post on like how hot is your hunt team, and gave you some really good metrics around like, hey, do you detect this, and being able to rank things. And so I really want to make sure this was captured as a resource, because he's done a lot of really good work on like when we do an atomic test. So we're going to break it down in a minute. Like, I run this test, what are the inputs, what are the outputs, what are the expected detections, and that really drives helping us keep tempo, because if we take small tests over time, when somebody actually comes in, we've built up a base where we can actually intercept or detect that earlier on in the chain. So that's kind of what our theory is, and things that have worked for us. So I'll let Keith talk a little bit about the cycle. So think about how you might use this in your environment. We'll get into the details in just a minute.
Yeah, so this is pretty basic, right? Kind of like a very simplified, just intelligence improvement cycle, right? Where you start like collect as much as you can afford, right? And that's, I think, one of the things that that it's not like we've been trying to reinforce for a long time, like as an industry. It has some interesting outcomes, like so you can do that. If you don't do it judiciously, it can do more harm than good, right? So talking about, thinking back about like the capabilities of your team and your ability to understand how you can operationalize data and things like that. You have to be a little bit careful in what you try to do with it to make sure that you don't spread yourself so thin that you're not doing a good job looking at any of it. But collect as much as you can afford. Focus on detecting classes of attack, and then measure and improve. So that second one, and really the example we'll kind of go into is, when we talk about testing, yes, you're testing, start with like a specific square on that matrix. All right, we're going to go test this specific technique. We're going to make sure that we can detect that. But the goal is always to like back that detection out as far as you possibly can, right? You want to abstract the technique or the actor away from that square as far as you can, maintaining your ability though to analyze and respond to the events that you're generating, right? So what the way that we think about this is kind of the difference between suppression and alerting, right? We refer to this as embracing ignorance in that, you have no idea what's going to come next, right? And so it's like the easy thing to do, again, is like to be reactive, to continue to like look at controls and even to look at detection, like in a very narrow way, and just, you make progress through those boxes, you start to fill in more of those squares over time. Like it makes you feel great. But the reality is, like over time, there's a pretty high operational cost to that, and so, we like operation, like looking at observations and alerts is probably like the biggest like change we've made in how we've operated, right? So like when we design detection systems, Focus on putting as much information that's relevant in front of analysts as you can, instead of focusing on what I would refer to as an alert, which is like a very concrete detection of a very specific technique, right? And so, visibility is even like easy to come by, but the problem with like alerts, like they imply accuracy, right? And accuracy is like, you think about it in terms of controls that we all know, like accuracy is like the AV problem, like exactly, right? It is a deadly accurate thing, but it needs to be. It needs to be sent out into the wild. It needs to be hands off. It needs to not disrupt the person who's using the system. So AV is extremely accurate, but now like that's obviously come home to roost, like in a pretty specific way. So how do we do this, right? We do this by kind of embracing false positives. And instead of trying to design alerting systems and detection systems that are laser accurate, instead we've just focused almost all of our energy on designing systems that allow us to deal with false positives at scale, right? In like a very basic way. So how do we do that, right? We do that by getting rid of what's good. So, you take in all of your data, you design suppression systems, and this is not it's not a trivial thing to do. And like part of the difficulty is that like no good systems exist to do this today, right? It's very team dependent, it's training dependent, but it's it's the only effective way to get this done, right? So you want to bring in as much of that data as you can, and in some meaningful way, like the goal is to look at, as close to 100% of activity as you possibly can, right? You're never going to get all the way there. But if that's what you're pushing for, right, you want to use your people, use your most expensive and your most, your limited resource to get through the most important things, the things that you haven't figured out how to codify and automate yet. And then you deliver a capability that allows analysts in a very fast and efficient way to look at all that data, describe what's good, and keep the long tail of that good stuff out of their way, right? And so what you've done is like you've effectively cast this net that makes very, very few assumptions about what you're going to want to find next. You just make the assumption that it's always going to be easier to figure out what's okay and set that aside than to try to predict the future, right? This is the sub-T Twitter problem. So it's like, I'll let you have it.
All right. So this, we wanted to get sort of practical. We talked about a little bit of theory. We wanted to talk about so what does this actually look like for a detection for an organization? So, what we're going to use RedServe 32 as a basic example. Okay. So everybody's probably familiar with this attack. But I wanted to take you through the history and kind of let you know what I was thinking as I explored this, found it, and what it looked like for somebody detecting this attack when it was first seen. So around April 2016, I found this really interesting binary that actually will load a scriptlet from a URL. Most of you have probably heard this. So I posted that on April 19th, and I was like, hey, this is really interesting. I think this might be something that, we want to explore, later. So, some people have asked, what were you thinking? How did you find it, or what came about, and why was it important, as a red team, to use this particular tool? So, probably some of the weird stuff that came out of this was this headline about Squibbly-Doo, the weird, name that I picked. I didn't think anybody would ever pick up on that. I named it, and I was like, I don't know, nobody will ever care, and it freaking got everywhere. So, I named it as an industry troll for naming things. So I gave it this I really want to see Squibbly-Doo on the RSA floor. That's my goal, really goal. So what was I thinking with this? So definitely I've been inspired by Matt and Chris's talk on living off the land. I talk about that all the time. I embrace that in an unhealthy obsession, right? The idea is where are the weird tools? Where are these things? MS Build, install util, all this stuff. So when I looked at RedServe 32, what was interesting to me was that it drops an XML file. And we already talked about if you're going to drop a binary to disk, there's huge scrutiny on that binary. So if you're writing text files or XML files, they're just not that interesting. You just can't watch every text file written. And then even better, it actually pulls this thing in from a URL. So what I was ultimately looking for was something that Joe hadn't seen before, right? I was looking for a tool that the idea was everything I was doing was getting detected very quickly. And so I was really the root of looking at RedServe 32 was I was just looking for something that I hadn't seen or that hadn't been used. I wanted to test and find that. So I was really just looking at observing the tool, I saw that when you registered something, when you actually registered a scriptlet, it wrote a registry entry, and it actually had like a file path, but it was like file : / / and I was starting to think well, that kind of looks like a URL, right? So then I started looking at Procmon and seeing, well, what if I change that reg key to a URL? Will it actually make the call? And sure enough, I was kind of surprised when I first saw that. I was like, that didn't just happen, but it sure did. So it's pretty cool. Just digging into it, that's kind of what I was thinking, this tool. But I want to take you through a story of so that happened. I then used that on an operation, and how does that actually make us better? Keep that tempo. How do defenders respond to something they haven't seen before? Most people have seen this now, but it was kind of novel at the time. And so this is just one component of the matrix. So when we talk about those atomic tests, the idea here is you can look at this one type of attack, whether it's PowerShell or RedSurf32 or persistence with a scheduled task. You can get some atomic tests around that. Let's see what kind of testing we can detect on RedSurf32. And then all of a sudden that starts to fan out. And as you get a detection for RedSurf32, all of a sudden you're well, RedSurf32 calls into a PowerShell, or RedSurf32 was called from a scheduled task. And all of a sudden you start to get coverage in areas you may not have anticipated. So the idea is, how do we broaden that detection coverage and see where we can go with it? So one of the fun things about my role prior was sitting at the bank that I worked at, was being able to sit in a seat where I could test things and then get immediate feedback on detections. And I encourage anybody that has that opportunity to I call it the "did you see that?" Running something and then immediately turning over into a tool and being did anybody see that? There was no detection. What just happened? Earlier, I mentioned that on April 19th, I had found, RedSurf32, and I came into work. I'm going to use this. They're not going to pick this up, right? So, you can see there's a detection that fires when I get into work on April 21st. And I was damn it, Joe, I just found this. The OPSEC on Twitter, I'm stop tweeting these things out, right? But the idea is I wanted to share how it was caught, because you have to kind of understand, it wasn't caught because they had seen RedSurf32. It was caught because RedSurf32 spawned some PowerShell, which there were some detections for, and then they were able to work back and say, what happened? Where did that come from? Oh, it was this. We haven't seen this before. Let's drive that now into detection. So everybody talks about attackers, or what I'm trying to think of the phrase, attackers only defenders have to get it right all the time and attackers have to be right only once. And the reality is attackers are going to make mistakes too. They're going to use terrible tradecraft to drop a binary. They're going to do something where there's visibility, and then hopefully we can work back from that. At least that's our theory. Again, we're open to being challenged on that. But so you can see in Joe's notes here is someone was using CLI flags and initiated execution, remote execution at another location. So the idea, once I got over, I was I'm going to go find that original detection and see what the hell happened. So let's break it down, right? So this weird thing shows up in your environment. You start looking at it as a defender. You're there's actually some discrete components you can actually break down in the attack. Again, as long as you've got that minimum viable level of collection, there's some things we can look at. And again, I encourage you to check out Zach's talk on ETW. There's some neat ways to break down, this is kind of my wish list. What if you don't have it? Start making that list of things you want to collect. So what process ran? What was, and more specifically to process name, be sure you're thinking about what's the original file name on the binary, because you could rename RedSurf32 to something else. So there's some good indicators there, what does it load? What mod loads occurred? What was on the command line? Were there network connections? Yes, and who and what port? So there's some things that you can sort of discreetly break this down. And then as a defender start to get visibility and coverage. So again, I just want to kind of share that idea, RedSurf32 wasn't initially caught in our environment because we had detections for RedSurf32. Nobody had seen it at that time. What was happening was there was other coverage that then led back to being able to drive the detection. So hopefully that makes sense. So.
Yep. So talk a little bit about the process and ultimately how we detect this and things like it, but more importantly, the kind of the process that it went through once we saw this one for the first time, right? So what was interesting, as Casey mentioned, we hadn't seen this before. We had no direct coverage for no one's watching RedSurf32 doing terrible things. But we're watching a whole bunch of other stuff, right? And the idea is when we start talking about observations and really dealing in very broad coverage and taking that kind of positive approach of just saying, all right, this is okay, and set it aside. This is kind of the process that we go through doing development for these types of detections, right? So this one, this I refer to as kind of like the AV detection, right? This thing is deadly accurate, which is great, and that it's never going to throw false positives, but it's terrible, and that it's also going to be like the easiest thing in the world to bypass, right? And so, again, going back to like a lot of the, you know, the pitfalls and the challenges we have with legacy controls is that they, you know, attackers just like turn the dial just a little bit, turn the dial a little more. Like this is like the crimeware problem, right? Like you just a never ending series of really, really small changes that make it extraordinarily difficult to look for this stuff in a pointed way. So what we do is take that stuff and you back it out, right? So we say, all right, we're going to take this process. Now we're just going to look for like this one thing on the command line. We're not going to worry about like where the remote resource was stored. We're not going to worry maybe we're not going to worry about some of these command line flags. And then we're going to say, all right, like anything that like does this on the command line and then has network activity, we want to look at, right? So you've kind of like, you've widened the funnel a little bit at the top. It's still pretty dependent like on that vector. So then you just go a step further and we started to say, all right, like maybe just like RegServe 32 doing anything at all in the network. Like we're going to assume that's terrible. We're going to look at that. And now you've got pretty much full coverage, like in any remote resource utilization, still limited to the vector. So then we kind of like take a step back and just unwind, right? And I think this is where, and this isn't a new concept, right? So like I'm like an old like packet monkey at heart, right? So like writing IDS signatures, like you find the bad thing and then you try to like back that out, figure out like what parts of the protocol can't change, which parts can, and you want to get that as broad as you can. Again, without overwhelming your resources. So, but the concept is where there's one, there's many, right? So like you see this. So like at the same time that, you know, we're focusing on like RegServe 32, like Casey's pissed, right? And so he's like back in his like laboratory, wherever, like whatever you, like, what do you wear when you do that?
Nothing.
Good. Yeah. So Casey's back like naked in his, I don't know if I can talk about this anymore. So like he's on to the next thing, right? He's on to run DLL 32. And then there's this whole host of things. Like you've got an entire operating system worth of like attack surface to work with, right? And like attacks are, like just look at the stuff we've heard about in like the last 48 hours, right? Like increasingly clever, not all like overt misuse of utilities. Like these aren't all vulnerabilities that can be patched. Some of these are fundamental like platform problems that can never be fixed until that platform goes through like a pretty substantial overhaul. So we unwind and we think about this, right? And like, again, not a new concept and everyone talks about it. Like implementation is difficult, right? So, but what it looks like when you get it right is that like, unfortunately, like, yeah, now you've got outstanding coverage, right? So we're just going to say anything in System 32 that talks in the network, we're going to start to watch. And, you know, over time, you start to suppress those things, you know, based on a number of attributes of the processes and the data. But like, this is the problem you end up with, right? So like, how do you strike that balance in like some intelligent way? And so we kind of think about this, like the concept of like the heads up display, right? Like, what are all of like, not all of the observations, but like what are the right observations like that analysts need most of the time to make a really good decision? And like you are not going for like 100% representation of all the data you have. It changes very, very frequently, right? So you always want to be dialing in like what you're showing to the operator because like they're easily distracted, they're overwhelmed. And it's really like the burden is on you as the person designing the systems and the process for doing this to make sure you get it right. So like, how do we practically approach this stuff, right? So like you kind of look here, like the source name up in the top right. So like this will give you a sense for how like you can build out that type of coverage, right? So we'll just start, and this is, we'll stay like any Windows CLI tool that makes an external network connection, like bam, we're going to look at that. This is how KC got caught, right? Again, didn't get caught by RegServe 32, but as is the case with almost every attack, right? Like everyone loves to talk about like memory, but the reality is like there's a limited number of things you can do without ever moving out, right? Sooner or later, you've got to move, right? You've got to move data. You've got to move between processes. You've got to move between systems. And so like, if you do this well, you can design a system that doesn't depend on like what the attacker is going to do next. And maybe doesn't like, you can have an entire row in that MITRE matrix that you just can't cover with the data you have. But like sooner or later, they've got to move. And it's not all mistakes. Some of them are just realities, right? Like so some of it's sloppy tradecraft, but more often than that, it's just like you have an objective, and like the only way to get from where you are to where you need to be is to move. And so that's the easiest thing to find. Like 5 years ago, movement was just introduction of new code. You can't do that anymore, right? Well, you can do that, sadly, but like the assumption is like you talk about kind of like, the apex red teams, right? Like really, really high functioning folks, like new techniques, operating in really tightly controlled environments. You can't do that. You can't just sling new code and move around. And so what you do is you start to look at things like in that way, right? And so here we can just see like simple PowerShell, like it makes one network connection. It's legitimate. But like this is a case of something that we'd suppress, right? I'll show you what that, like talk through how we do that in a second. Another example, right? Like anything that's going to write something to system, like period. Any change to any like system file or directory. And as Casey mentioned, like the cool ways that you can kind of buffer that coverage, like under the hood, like don't just stop at saying like things in this directory. Don't just stop at saying things signed with publisher, because we know that's now a total dumpster fire. So, but you can look for things like binary internal names, right? Like maintain a big array of binary internal names, and then just like we've seen in the wild, like run DLL32, right, for a long time, and I don't know if we still see that today, but like run DLL32 getting renamed and dropped along with a payload, right? It's a signed file, it'll run, but like that thing should not be running from your browser's temp directory. So like those are the types of things that you can do. Like again, this is an example of a simple false positive, but like if you chain these things together, what we basically do is just take all of the attributes of that process and say, all right, like if you look back at it, like this hash with this command line running in this user context on this system or all systems, we're going to say is okay, right? Like we validated that thing. You can go a step further than that and like do this based on, specific actions that like processes have taken, binary attributes, things like that. But that's it. Like you take those things and you start, like you suppress those and you set them aside. And now we no longer need to know like what new PowerShell tradecraft we need to worry about, right? To take this as an example. And then like in this case, like, you kind of abstract away even the specific tools and just say like, we're just going to lump all of the, like any Windows, like command line or scripting harness, like we're just going to treat them all in like the same bucket of awful things. And we're going to watch them all in the same way. And so you've really you've expanded so far out into this class of attack. And you rinse and repeat that for, all these new tools and all these new techniques, including like things like external enrichment, right? So, you take a file that gets dropped, right? It gets put on the system. Yeah, maybe the endpoint can lie to you and tell you that it's signed when it's not, but like you've got the hash, you probably have the file, you can take that thing off into another system, automatically run that down really, really simply and say, all right, like if there's a mismatch between signing, or between file pedigree, between a trusted system and an untrusted system, then you've got a problem. So like just taking that approach of just like, get as much coverage on things as you can, like design systems. This is possible to do with like some existing SIMs, like tools like Elk and stuff like that are starting to make this like a lot more accessible for blue teams. You've got a lot of control over the system that you didn't have before, right? So like, think about doing this 10 years ago in ArcSight, like totally impossible. Probably still impossible. Yeah. But fast forward today, right? Like you've got all these tools and all this information at your disposal, and just like think about it in a different way. Just like flip the whole thing upside down. Don't worry so much about accuracy on the front end, and just take all that energy and focus it a little bit like farther to the right in the process, and you can just yield some great results.
So hopefully this is some things that are helpful to you. Hopefully we've given you a couple practical things, some tools to talk about. So kind of wrapping it up, and we wanted to leave a little bit of time for questions for us as well. So we hear the phrase a lot, red team always wins, right? Like the idea that like they're going to get in, they're going to compromise, they're going to do something that always, red team will always set the initiative, right? The attacker sets the timing and velocity and tempo, right? They're going to start the engagement, so to speak. We don't really have the control over that. So they set the pace, they set the innovation of the attack. But there's also some things that hopefully we've shared that you can do, like as a defender, that you can bring, come alongside once you're starting to see that activity and begin to work, to detect and move at the same pace. Like we kind of use the phrase, like, you might get in, but you're going to have to fight your way out, right? Like the idea is, it's going to be a lot more difficult once we know you're here, to get stuff, out of the network. So some of the blue team, things for winning, you can kind of touch on those. So.
Yeah. I mean, and yeah, most of those are pretty basic, right? So it's like visibility, like you've got home field advantage, right? Like, your systems, in theory, your systems like better than your attacker, right? So, and yeah, just like, overall, and I think like maybe even the bigger part of it, right? And like I think the big takeaway and the way that we've operated is like, it's not a red-blue thing, right? Like someone whether they pay you or whether you're their customer, like whatever the however the relationship's structured, it's not a red-blue thing, right? Like everyone's on the same team. Hopefully everyone has the same objective, which is to, learn from successes, like share failures. And like, it really just like, think of yourselves as like one unit, like share openly, like just those relationships, I think, are the things that like matter most. And you think about this conference, like in the way that, there's been a lot of talk about like celebrating failures, maybe not celebrating them, but but certainly being open and sharing them, right? And that's, a lot of the, like a lot of the traditional like red-blue way of thinking is that it's like you're on this team or you're on this team, and just like bringing those things together, like treating one another like a lot of transparency and a lot of respect, has like it goes such a long way.
Yep. So yeah, so again, so I don't want to. We'll take a couple questions, but I don't want to hold everybody hostage for questions. So I'll take we have a couple minutes for questions, and then we'll kind of wrap it up. So feedback for us. Are there any questions on things that we covered today? Comments or thoughts? Question in the back.
How or do you revisit any of your suppression rules to sort of ensure that they're not too broad and you're not missing out on things which were bad, like you go back to them?
Sure. So the question was, for those of you, do you go back and revisit suppression rules or detections to make sure that things are not being missed or not detected later on? Is that the question? Okay. Yeah. Okay.
Yeah. So, to do that in a couple ways, right? So, we mentioned measurement and didn't talk explicitly about it, but like, really simple stuff. So like you see the source up there, right? So like every piece of detection criteria, which in theory maps to like a specific technique, just gets a score, right? So like out of the gate, its score is nothing. And as analysts make decisions, you increment or decrement that score. So like you could do a couple of things, to kind of buffer against that. One, like everything ages out, right? So like no suppression rule is permanent. That's probably the most important thing. Like nothing lasts longer than say like 90 days, no matter how accurate or like how good of a decision it was. And then you can do things like, you're going to have some detection criteria, like just because like one of the things that we really like work hard on is like getting really broad coverage, right? So like you detect the threat, if you only detected that in one way, right? So like if like one little detector fired, that's pretty fragile, right? Like even if that detection technique is broad. So what you want to do is like get a lot of coverage on those things. And as you start to learn, which detection techniques are more accurate, if someone makes a decision to say suppress or hide a detector that we know, 99% of the time results in something terrible being like passed on, like just, re-inject those things back into the queue. Like that's your QC pipeline, right? So does that answer your question?
And I think the only other thing I would add, which we didn't get completed for DerbyCon, we wanted to release what we're calling our atomic testing, and we've got it. We're hoping by mid-October we should have some completion there on unit tests. So we've been working on things that we think will be helpful, and we want feedback for other people to contribute to be able to say like, hey, here's a detection for this, or here's how you execute this. So we're open to feedback